So my name is Kathy, and this is a session about GitHub Classroom. So very specifically, I want to talk about what this isn't about. This isn't about Git. It's not about GitHub, where I'm definitely not going to show you how to get any files into your repository or anything like that. But I will show you some sort of like different ways if you want, but it's not like, this is not the crux of the talk. Most of this talk is actually about repository management and teaching using GitHub as a tool. So I'm going to actually do this seminar by doing what I do as a class for my students. So whenever I start a course, so I teach college, and typically I have about 40 students per class, usually. Sometimes there are less, sometimes there are slightly more, but around there. And typically every semester there is somewhere between 2 to 4 classes, depending on what other work I'm doing. But so we're looking at 80 to 160 students, individual students for the entire term, which is a lot of repos to manage if I have to do it manually, so I don't. What I do is I actually do a few things through GitHub. So I'm going to actually do what I do with my students, and I'm going to send a link, and I want you all to actually join this link right now. So why is this not working? There we go. Is that the right link? No, that is not the right link. Hold on. Let's see. Sorry, I think Zoom chat's being weird. Okay, that's the correct link. Okay, so there I have posted a link. So if everybody goes into that link, and you will see a box that has a join button on it, just hit the join button. Okay, so I can't do it anymore because I've already joined. Oh, actually, no, I can do it through here, I think.
So people have to have a GitHub account to do this?
Yes, you do need a GitHub account to do this. I'll open it publicly so that you don't have to in a moment, okay? But yeah, you do need a GitHub account. But once you have a GitHub account, you can just simply hit this join link, and it will allow you to join the repository. Okay.
So before we can accept this group assignment, it says we have to join an existing team?
Yes, join an existing team, because that's the only one you can do, because I've only got one team. So everybody joins the same team. And so even though it says assignment, ignore that, because there's an equation for, it's a GitHub Classroom thing. It's not actually anything. So what I'm doing here is I'm actually opening up a course repository for everybody who has the link. So those of you who, so this is the repository that you see. I will make this public in a moment. Currently, this is a private repository, so only those people with access can see. So for example, if you're teaching, you may or may not want to display the coursework, the course material publicly, right? So this actually is a way for you to very quickly give out the course content without actually making it completely public, and also without actually having to figure out who all your students' GitHub IDs are and then adding them to the repository. This is actually one way that you can do this. You can actually set up a repository and do it in a way through GitHub Classroom that only allows one team to exist, your team, and therefore allow them access to the repository.
Kath, before we get into too many details, could you maybe give everybody sort of a big picture of GitHub and repositories and how it all gets used and who uses it, etc.?
Okay, so I'm going to do I'll do a very brief intro blurb. So GitHub is based on something called Git, which is a revision control system created by Linus Torvald for the Linux project. So GitHub and Git are actually two separate things. GitHub makes money by putting a web interface on top of Git. That's their business model. Okay. And but having said this, most people don't actually know necessarily. They don't necessarily use Git the way that it was originally developed. Most people actually use Git through GitHub. So knowing GitHub is actually pretty useful. It's sort of like in terms of professional work, it's expected that you know how to use GitHub at this point in time. So like when you know, one of the things that our students have to do is they have to learn how to use GitHub properly. And now there's different ways, but GitHub is a very powerful tool, and it does a few different things. It creates, it allows you to create repositories, which actually is simply a set of files. Okay, so this is a repository that you see on the screen right here. Am I still sharing the screen?
Yes.
It's hard to tell. Okay, so here are all the files in a repository. And this is stuff that I want to share with my students. So this might be a little, a piece of code with some analysis in it. We were talking about, this is just from my course. And so I can share with my students this piece of code. Now, this file has nice syntax highlighting. So you can see that like the code is actually syntax highlighted. And I didn't have to do anything to make it look pretty. Okay, this is exactly the same file that I have on my local computer. I've just put it into GitHub, and therefore, and GitHub knows how to deal with a regular source file and make it look right for whatever, for the syntax. So whatever language you have, GitHub knows how to do it. You can, a repository, but isn't just about code. It also contains a bunch of other tools that let you work with the code. So for example, one of the things that you could do is, let's say that this was your student's work and you wanted to tell them that there was a bug on line 10, for example. So here I'm highlighting a bug, right? There's no bug here, but let's say I did. You can actually do things like this. You can actually click on the line number 10, click on the ... copy the permalink, and you can tell them, open an issue and say, bug in bug. And put in the permalink and let them know that this is a bug. And if you have a large enough source file, this will actually highlight what is wrong, but it will also give them a link back into their code exactly where you meant the bug to be. And that way, if you want to give like really accurate feedback, you can, like literally you have a bug in these 3 lines of code, the memory leak there, whatever it is. And so it's a really powerful tool for talking about very specific things within your code. You can also see who did what work. So if you're doing a group project and you want to know who submitted what piece of code, you can do it down to the line level. So for example, here you can hit blame, and here, if this wasn't a starter file, you could actually see who actually wrote the code down to the line level. So if there was multiple authors to this, you would actually be able to see a line and it'll say this person did this or that person did that. So it's an incredibly powerful tool for talking about code. So it's the files for your project, and then a whole bunch of tools on top of that. You can also use it to host a website. Okay, so I actually have websites that I create that actually lets you do hosting. So this is this one I know is GitHub.io. So this is for example a website, and if you take a look at the URL, it's got a GitHub URL because it's actually hosted from my GitHub repository. So you can, so this is like from the point of view of the user, this is just a regular website. You can like click on the buttons and everything and whatnot, but it's a website that I'm not hosting it off my own web server. I'm hosting it through GitHub. And those are all the things that you could do with GitHub. It's actually an incredibly powerful tool. And you can do it for several things. So here, what I'm doing now is I'm actually using this repository to host course material for you. And I have this for pretty much all the courses that I teach. I actually host my course materials on GitHub. Typically, my course, any code examples I do go inside the code tab, and all the course documents are in the wiki. So everything that I talk about, if you go to the wiki tab of the repo, you will actually find all of this material that I've written out for the talk. Okay, so there's some background. So if you're not familiar with GitHub, there's some background material that you can get, and I'll go over some of that soon. But there's some background material, and then some how to do certain things. Okay, are the wikis edited in Markdown? Yes, the wiki is edited in Markdown. Okay, so so if you want to do wiki editing, you just write in Markdown for GitHub. You can change the language, I think, if I remember correctly. I haven't. You can actually change to a different language inside the wiki tab if you want a different wiki style. So if you know the other ones, go ahead. I find that Markdown is actually pretty good, very consistent, very easy to use. So.
We had a question about whether or not GitHub could do plagiarism checks.
Not by default. No, but I'll show you a few things about Classroom that will help you out. Okay, so GitHub is like learning to use GitHub is actually pretty big, and I didn't want this talk to be sort of about how to use GitHub. If you want, we can find time and I can do a GitHub session, but I really want to talk about Classroom today. So Classroom was what opened this particular page to you. And the reason that you might want to do this is, as I said, you might want to share your repository, your course material, only with your students. So how do you do that? Well, you can make it public and hope nobody ever finds your URL, or you can make it private, and then you have to somehow get all your student GitHub IDs and then give them the access, right? So this way, what I'm doing is I've set this up as an assignment in GitHub Classroom, and then told all the students to accept that one assignment, and then they have access to the repository. So that's sort of the way that's done. But let me talk about something else. So now, as a student, if you were participating in a course and I wanted to, I usually, do you post PDF lessons or as well, or mainly instructions? So my instructions are usually written in Markdown. I find that that is the easiest way for me to do things. It's just generally I find that all the extra editing features I don't use. But you can post a PDF. There's no reason you can't. You can put it into your course repository as a code in the code tab, or you can link to it from your wiki. There's different ways to do that. So that's okay. So a couple of.
Could you read the question before you answer it? Just so people know what you're talking about.
I'm also reading. I'm reading some other questions. Okay. So if a student commits a change to that repo, is that change seen by all, or is the copy of the repo for the individual students? So the students do not have write access. Okay, so that's one of the main things that you do first, is that the way that you have to set this up is that you actually have to take away permission manually so that they don't have write access, because this is the course repo, it's my stuff, it's not their stuff, right? So the first thing I do is I actually take away any write permissions that the students have. They only have read permission. And then the next question is, so no, they can't change it at all, which is okay, because this is not what this was meant to be, right? So next question, have you stayed on the free version or had to go paid level? So the answer to that is that this actually has changed over time, what is free and what is paid on GitHub. So when I first started on GitHub, you pay for privacy, which means that everything public was free, everything private was you pay for. And then a few years later, they changed it to, oh, now you can have free private repos, but only if you don't collaborate with anyone. So that was actually something that was changed. And now recently what they said is, no, you can have private repos too, but there are certain tools that we will actually remove from your private repository. So for example, I actually did this over here. So this particular account, this account of mine, doesn't have any paid privileges. And what you can see is that a private repo here, you notice that there's no wiki tab listed, like there's usually a wiki tab somewhere on here, and it's not here. So whereas on my paid account, you have a wiki tab. So things like certain features are missing. GitHub Pages is missing from private repositories at the free level. I would suggest that as an educator, you get yourself upgraded. Like go for the educational discounts and they will give it to you for free. Okay, so you don't have to pay for it. So it's at the paid level, but I never paid. Okay. From Jamboard, if you share your lessons with students in a private repos, can't they fork the lesson and content and take it with them? Well, they probably can. I believe that there are forking rules about what they can share beyond, like they can share it manually. And also the things that they share are in the code section. Even if you fork, I don't think you can fork the wiki. You don't fork the wiki, you don't fork the issues and things like that, I believe, if I remember correctly. So maybe, but I've never had a problem with this. It's either this or, in any case, it'll be public, right? So helpful to do you as like everyone else, I have to learn more about LMS delivery model. Forking is disabled. Oh, forking is disabled, there. So no forking. You can clone your files, but what you clone is always, so the question is, I think you can clone locally, then share the files. The answer is yes, but what you clone is only in the code tab. You can't clone the wiki, you can't clone any of the other things around it. So if you say, I honestly don't care if they share, like my code, who cares? It's like, factorial, who cares, right? Share it. They can. And that's okay. So they can, but it's limited to what you put inside the code tab. Cloning doesn't clone anything else. So most of my course documents and things live outside of the code tab. The code tab is mostly just for code files. So that's what it is. Okay, so now let's go back to this. Now, Classroom is, so this is an example of Classroom use where you're setting it up for them to see your work. Yeah. So I usually, it depends on what you want people to link and what you don't want people to link. So that's what it comes down to, Ross. In any case, sorry, let's go back to Classroom. What I want to do is I want to show you how to set up a student repository for Classroom. So a student repository for Classroom, here is another link I want to share with you. This one will allow you to become students and create labs, a lab repository for yourself. So the second link, if you click that one, what that will do is it will allow you to create a repository for you to give me work in. Okay, so this one is set up differently. This is your lab repositories. Now, there are actually instructions that I have that I was going to share with you. So if you go to this link, what you will get is you will get this. Now, when you create your team, I want you to actually use your name, your first name, for your team name. So instead of just like creating the team, create it with the first name. Some do, some don't. It depends on what they teach. Some of my colleagues do, some of my colleagues don't. It depends. Okay, so first of all, this is really important. So after you've created this team, okay, this is actually about repository ownership. So one of the key problems that we have, and this is where I actually have slides for, is if you create a repository, the repository is owned by someone, and the owner is either an account, an individual account, or it's some sort of organizational account. If you have your students create, for example, if a student creates a repository and then gives you the link, they own the repository, which is fine, but that also means that they you have to always look up what their repository is. Like you have to actually track this information. And B, you also have to always it also means that if your students decide to how do you say this? If your students decide to delete their repo, they can, which may or may not be something that you want to let them do. They can also admin it completely. They can share it with whoever the heck they want and so on. You have no control over this. So instead, what I have is I don't have that kind of ownership. Instead, I have it so that the ownership belongs to the organization. So what do I mean by this? So now if I'm going to, let me refresh this. So a whole bunch of you have already joined my class, right? And if I go back over to my course repository, ACE course, so over here, if I go back to the organization, sorry, this is the ACE organization. So what you see now you see that I have a whole bunch of labs, Lauren labs, John labs, Adam. But if you go to this URL, so those of you who have joined, if you go here, you will not see any repo except for yours and the course repository. So you will see the course repositories, the course repository, and the repository that you made. That's it, just those two things, okay? So what's really cool about this is that I can actually so I have everything is actually listed inside my organization. So I'm not looking all over the place for things. If I'm looking for a particular student's assignment, so I'm marking and I'm looking for grants assignment, I just type the word grant in the filter here, and it will list me all the repositories that have the name grant in it. So that's why you have them use their name in the team name, because they have this. But outside of the organization, no one knows these exist because these are created privately. So even though their names are there, even their classmates don't know who's in it. So so for the teachers, you can actually see, you can see everybody. But for you guys, you could only see yourself, which is pretty nice, because then you can actually have have some control over the existence of these repositories. And if you needed to have it so that the students, if you needed to keep a copy, for example, like I don't know about secondary, but we actually have a policy of keeping student work for 1 year. So if my students delete their own homework because they have control of the repositories, that's actually sort of a problem. So this way, after a year, I go and delete the entire organization and it's done. But within the year, it doesn't get deleted and it's there. So that's sort of the things that you can do to sort of some of the things that you might have require.
So is there a workflow? I just changed mine, just directly modified a file, but is there a workflow that I would I just did a commit if you looked at my...
Okay, sure. So here is Grant. So Grant has done some work and I can see that he's updated lab 1. Now, if I was marking this, right, there would be some different things that I would do. So for example, if I wanted to mark an assignment just using GitHub, and all I was doing was looking at the code and I don't really care about it compiling or whatever, I can just look at it, okay? And then say, okay, this is 10 marks, 3 marks, whatever it is. And you can give feedback either through your LMS, through your issue tracker, however you want. There's no rules about this. I can make a comment and I can, do things like this and provide feedback. And these are templates that I've actually set up to do the feedback. This is actually the lab template that I use for my data structures course. So I can give feedback by just typing in, hey, nice, whatever, and then submitting the issue. And now by doing that, the students also have feedback in their repositories. so this one is set up pretty, like I've done a lot of setup work for this. So it's neat. But in any case, students have this repository that they can do to build this. Okay, so this is really what GitHub Classroom can do for you. Now there are, any questions about this so far, like what it can do? Because now I'm going to demo how to do it. The organization, I would recommend one organization per course, per semester, or at least one organization for course. I used to have just one organization for the entire course, but then there was 40 students a semester, multiply it out through many years, and you get a lot of repositories. So now I do one organization per course per term. But if you have less students than me, you can definitely just do one organization per course, right? So there's advantages. It's just a matter of organization. It doesn't really matter which way you go. Are there any other questions? And I'll show you how to do the setup. Okay, so let me show you how to actually use Classroom. So the GitHub Classroom app, so first of all, one very quick note, there are two, any start from scratch tutorial link on starting from no background. Depends on what background you want, because Git itself is like this crazy thing, right? So because I only had half an hour, I didn't want to focus on Git. But if you want some Git tutorials and GitHub tutorials, I have some as well. I can link it to you. And there's also this. So if you go to education.github.com, over here, this is not Classroom, but this is where you get your discount. So somebody asked earlier about, do I have to get the paid level? You can get the paid level for free using education.github.com, and they will give you, there's literally a button here that says get benefits. So you can do that, get benefits for whatever it is. And I've already done it, so it doesn't show me anything. But if you were going in there for new, you use a school board address to be approved faster. They don't like Gmail addresses these days. So use a school board address. Your students using their official address can also get benefits as well. They have a student pack that they give away, which is like AWS credits and all kinds of other stuff. So lots of goodies in here that you can do and do this. Now, there's also a community forum. So if you have problems with stuff, github.education.community instead of .com will actually get you to the community forums. And if you have questions, this is generally a good place to ask. People who have more familiarity will be able to help you out. Let's see. So I'll link the starting from scratch tutorial in a second, but let's go to Classroom. So if you want to use Classroom, there are several things that you would need to do. The first is you're going to want to set up an organization. So simply go to your thing and, oops, not this, not that, github.com. And you go and do your organization, new organization over here, and you pick it for free. Even if you have an upgraded plan like I do, you start with the free one, join for free. And this is because it's an organization, it's talking about your team, and you create an organization account. Feel free to do this with me. This will be called ACE Demo 2, because I already have a Demo 1. Give your contact email at Seneca College.ca and your personal, say that's your personal account, verify, and I think I'm supposed to choose a spiral galaxy and hit next, and I've done this. Now I'm just going to complete the setup, and this will set up my thing. I'm going to just submit this without anything. So this is a an organization that I set up for doing this. Now, once you've done this, the next step is to open this inside GitHub Classroom. So over here, we have GitHub Classroom. And if you go to, so this is classroom.github.com. This is the application. So really easy to mix the two up, education versus classroom. Classroom is the application that lets you do all these, that has the tool. Classroom is the tool, and education is not. So if you go to Classroom, you're going to be able to do that. And what you do is you set up a classroom organization. So this is all of my this is all the classrooms that I have currently and before. So different semesters. You can see that there's like one for winter 2021, some for fall, and so on. So I have different classrooms and I use it for all my classes. Then we set up a new classroom here, and it will let you choose your organization. Now, this is, I don't know where it is. Might be in page 2. Oh, there it is, page 2, ACE demo 2. So this is the organization I created just a moment ago. Just click it, and it will do this, and then it has this classroom name. Call it whatever you want as long as you can find it. You can invite other people. So if you, I'm going to skip this. I don't have an LMS I'm using, so skip, and then we're done. And we're here. So this is what it looks like after you've created it. So presuming, so this is the class I'm creating. So presume once class created, it can act as a template for a second time teaching this class for the code. So when it comes to the repositories, I generally just copy what I need to from one semester to the next, and just upload the entire repository. If you, I generally like to start fresh because I want to introduce the files one at a time as I'm doing it instead of having like a batch of files. So I don't usually put everything in right away. I just put whatever I need as I go and then upload as I go to GitHub. Okay. No, not really. Either it's there or not there. So that's not, GitHub doesn't really have a hide and show. Hide by not putting it up. Yeah, and you can do that by slowly adding it and committing it to your repository. So there are ways to do it, but not on the web interface. Okay, in any case, here is this classroom. Now, the next step is, let's go with how do you create a repository for your students to submit their assignments. That's sort of the most common use case, right? Now, what you see inside, if you log into GitHub Classroom, by the way, if you don't know how to get here, it's just very slowly. Feels like a potato today. Hold on. There we go. So here is the one where you see all the classrooms. So this classroom is associated with the organization ACE Demo 2. And it says here that I can create my first assignment here. So I'm going to do that. Create an assignment, create your first assignment. And over here, you have an assignment title that you want to give it. So let's say that I wanted to create an assignment, call it A1, whatever I want. And what you see here is you have your assignment title, and then you have this little pencil mark that says prefix. So this prefix is actually going to go in front of all the repositories in your organization. So when I did that lab one, for example, ACE demo, when I was in the lab repository, I don't know what is going on with my network. It's really sluggish right now. When I did this, you notice how everybody's repository begins with the word labs, and that's because the prefix for that particular assignment was labs. So you can change this if you want. I'm just going to leave it as A1. Now, this is sort of the one of the tips that I'm going to give you. If you want your students to have individual repos, individual assignments, don't set it up as an individual assignment. So an assignment basically is the creation of one repo for your students, okay, or joining of one repo for your students. And so if you have an assignment that is a group assignment, you can use this to set up a repo that multiple people can access. If you have an individual assignment, you can do that. Now, if you set this up as an individual assignment, the URL is going to be called github.com, your organization name / their GitHub user ID. And honestly, I have no idea who like Bear33 is. So I don't want to use their GitHub ID for their repo names because I'll never be able to find them. I have to like look it up every single time, and that would drive me crazy. So instead, my suggestion is that you never set it up as an individual assignment, even when it's individual. You call it a group assignment, and you limit the number of members to the team to 1. And that will mean it's a group assignment with only 1 person allowed, which will be the only student, and you're fine. So this means that when they set it up, it's the only student there. Only they can see it. And this is how I set up that lab repo for you. I just use that. And then the total number of teams, just leave that because I don't know how many students I have. Repo repository. This is where you set whether or not you're going to give them a private or public repository. So if I don't want anybody else, if I don't want my students' work to be shown, just make it a private repository. Grant student access. This literally means they can delete the repo if they want. Don't do this. Groupings can't be blank. Oh, sorry, you have to have a name for the group. So I usually do something like A1 teams. Now there is a couple of like little caveats because I'm naming my teams a certain way, because I'm having them use their names. You actually should get them to, if you're doing more than one assignment where it's individual, you will need to ask them for you will have to ask your students to prefix their team name with like A1, A2. And it's okay, it's just an extra thing because you can't have the same team names, that's all. So in any case, we're running out of time. So the things are already there, but here this lets you select a GitHub repository to use as starter files, and then you hit continue, and then pretty much that's it. Add auto test, create your assignment, and what this will do is it will give you a link, and you copy the link and give it to your students, and then they hit the join buttons like you guys did, or the creation buttons. Because we're running out of time, I've actually written out how to do this, and I will open up this repository to be public so that everybody can have access. But effectively, this is all of the material that I want to talk about is actually there, and this is the link to it. So if you are looking for specific instructions, it's all here. Okay, so sorry I'm rushing that, but anyhow, I want to get moving so that the next speaker can go. I don't want to go too late. So let me just manage access and make it public. That's it. Thank you, everybody. Sorry that was rushed.
Thank you, Kathy. That's awesome. Okay. And it's recorded as well, so in case you want to go back and follow along, you could do it with the recording. So thanks. That was awesome.
Okay.
I've tried this before, but those little tips, especially the group assignment thing, it's probably very important.
Thanks everyone. So I know that was rushed. So
no problem. Can you hang on for the rest too? Yeah.
Yes.
Okay.
Yes,
cool.
Thank you.
So Ken, are you available to?
Yeah, absolutely. Audio check. You guys can hear me okay?
Sounds great.
Yeah. Okay. Well, yeah. No, it's always a pleasure to be here. I gotta warn you, I find that my brain just shuts off at 9 o'clock.
Got here for 10 minutes or 15 minutes and then boom, it's gonna explode.
You'll be talking to a zombie. Anyways, it's certainly great to be here. I have a lot to share with you, and let me just see if I can get Zoom to work here. So I guess I share my screen. Is that right? Yep. Okay. I have no idea if I'm sharing okay or not.
It looks good. Right. Okay. If it's a moon, it looks like a moon. Yeah.
Yeah.
There you go.
Things are coming. Okay. Well, so I prepared a couple of slides just after my lecture today, and take this more of as a as an entertainment and a workshop, it's very difficult to get things right. And don't presume anything I say has, decades of wisdom behind it, right? Like, because we have pretty much just like weeks and months of wisdom in the current situation of the COVID lockdown and 100% online education. So I kind of, in a tongue-in-cheek way, called this part 2 on computer studies education. And it's a bit of a double meaning. One is that I follow Kathy's lead, which was really great. I certainly learned a few things on how to use GitHub for education. And the other meaning I want to imply is that this is very much a continuation of the talk I brought to ACSE last year. So it didn't feel like last year, it felt like last decade. But it was 2020 that Grant invited me to give a talk, and I was, thinking about computer studies back then. And I think very much, I'm not sure if any of you were there last time other than Grant and Peter. But if you were, like, I wasn't very happy with the curriculum with computer studies myself. And I think there's a lot of room for improvement. I'm sure things are improving. And with COVID, there's some really interesting opportunities, in fact, that we can do. So, but anyways, I think things need to improve because this is like about 2 weeks ago where CBC had an article. When I was reading this, I wasn't quite sure how valid it is, but it talks about half of the adult population fell short of passing high school level assessment, and we're below average compared to other OECD countries, right? And this is Canada, which is, something that we don't really, like, we should probably do something about. And from an email, I don't know if any of you in the audience recognize, one of you sent me an email like last week or 2 weeks ago, and it had a really brilliant quote from Mark Gusdale about what computer science should be like in the ideal world. And I couldn't agree more, right? I couldn't articulate it nearly as well as this. The goal of the first computer course should be to promote confidence if we're going to increase diversity in computer studies or computer science in CS, right? So you really want to provide students this like surprisingly impressive experience that they achieve through technology. And that's what we want to do. Next one is Daniel Goleman, right? I've been watching a lot of YouTube videos because I'm stuck at home and my son is always on YouTube. So sometimes we watch YouTube together, and we ran into this psychologist slash journalist by the name of Daniel Goleman. I mean, many of you may know him. It's the first time I ran into his YouTube videos. And he gave this amazing talk. And in the talk, he famously said, information consumes attention. And I think it's very, very true. So, and something that I want to talk about in terms of how I teach computer science, and I'm really trying to like see how things can be improved, because it isn't all that great right now at all levels, even at the university level. So what I want to share with the audience is my experience in the past 12 months in dealing with the COVID lockdown virtual campus teaching at Ontario Tech University. I want to, like, maybe, I don't know exactly how to have a two-way dialogue, but so feel free to throw things into the chat, I suppose, to identify opportunities for education, technology, and pedagogy that can be applied to K-12 computer studies. And let me just actually see if I can copy this link and throw it in the, oh, somebody has done that. Oh, thank you so much.
I put in chat, yeah.
That's, I thought, Grant, that you are AI, because that's so responsive. Anyways, yeah, so I certainly would love to gather feedback from the audience, both today as well as in the coming days, on just, exactly how to get it right. This is the type of teaching that I have been doing. And, when Kathy was talking, the first thing that struck me was that, 40 students. Wow, I don't remember the days I taught 40 students. So with 100% teaching, we merge quite a number of sections so I teach 4 courses per year, 2 in the fall and 2 in the winter. I teach data analysis, programming languages, compilers, and machine learning, ranging from year 2 to graduate level. And you see the number of students are in the double-digit range. So in all, I deal with about like 400 or so students, and many face-to-face interactions break down. What's interesting is that with this kind of pressurized teaching activity, interesting innovations, I believe, like somewhat emerged. So lemonade was made, okay? And now, what is my job, at the post-secondary level? And then we're going to try to maybe decompile this into the K-12 level, and perhaps I get it right on some of the translations, and others I might miss the mark somewhat. So this is my daily job. I need to deliver lectures. So we do face-to-face video lectures. Because of the size of the classroom, we usually default to Google Meet because it can handle up to 250 per session. And I need to conduct tutorials, and I need to host office hours. And in fact, what's interesting is that the most challenging thing is office hours. Having this one-to-one without the physical space, dealing with office hour was more difficult than the lecturing. I also need to be mindful of students' computing resources. So students come to us and look at the course material, and then they need to do something. So especially in computer science, we tend to have this heightened level of requirement for students to have sufficient laptop and software capability. And in a face-to-face environment, that was easy to manage, with virtual, and some of my students, surprisingly, is overseas in a completely, not just one time zone off, but 7 time zones off. And then they have a laptop issue. It's like, well, what am I going to do? I need to come up with formative assessments so that students get this hands-on experience, this instantaneous feedback on how well they're doing, so that they can adjust their learning pattern across the 5 courses they take, right? These formative assessments usually take on labs, quizzes, and self-learning modules. And then we need to answer to the employers, and finally assign grade letters to the students and identify the A+ students from the lesser ones. And the summative assessments are term tests, assignments, and exams. And some of you have already brought up this issue of plagiarism, which is a real growing issue in this virtual environment. And the summative assessment is highly sensitive to the element of plagiarism and other type of adversarial attacks to academia. What I really want to have a disclaimer over everything I'm about to say is that we need to recognize the real limitations of virtual campus. The first and foremost is that no one has done this before, right? So any kind of experience that I'm sharing is probably me doing things wrong, and absolutely I'm certain that we're doing things suboptimal. So there's going to be enormous improvement if we're to stick with this virtual format, because it's the very first iteration, right? So this is a prototype that we're working on. So the final product, to say the least, will be a derivative of what we're doing. And because of the volume of students, I get response from this large population very, very quickly. And I was listening to the radio today about the fast iteration of COVID vaccine. And one of the silver lining of developing vaccine for COVID is how infectious the disease is. And therefore, it's super quick to test the A/B test effectiveness of different vaccines. So with a large number of students, there's a similar phenomenon. Whatever I do, I get this immediate feedback from the large number of students telling me what kind of issues they have. So my students struggle with hardware. You know, many of them have a 5-year-old computer that cannot install whatever Service Pack 2 or Service Pack 3, or if we need a C++ compiler, they just cannot seem to be able to put it into their hardware. They absolutely struggle with the software. We do use GitHub Classroom, and even at the university level, many students just struggle with Git. The network connectivity, with like students struggle with that. Students struggle with attendance. So it really takes this extra endurance for them to make it to the 9 o'clock lecture. And the interesting thing is that we make everything video recorded, and that actually certainly, as we can understand, makes it even more difficult for them to show up to class and show up to class on time. And all in all, I have had many students coming to my office hour just to complain and vent, not about my course, but just life in general. And I can see this very visible deterioration of mental health from the student's point of view. So this is virtual campus, all right? This is the way I'm dealing with university students. And I cannot really imagine things being that different for high school and elementary students who are doing this remote. So our solution, I'm actually very, very grateful that we have a solution to just kind of help us to cope with a fairly challenging landscape. There are two things that we have identified to be of particular gem in doing online teaching. Mind you, online teaching is significantly beyond these two elements that I'm highlighting, but I think these are really the top two that are worth sharing with this audience. One is Jupyter Notebook, and Jupyter Notebook has come up year after year in this particular workshop. I've heard Peter bringing it up many, many years ago, and I think last year some speaker, Grant, I'm not sure, like if I remember it correctly, but someone talked about Jupyter Notebook, right? Maybe it was me, I don't know. And Jupyter Notebook is an integrated environment for coding, for incorporating textbook material, as well as video instructions. So it's a one-two place or a go-to place for students to get most of the material they need to get things going. In recent years, Jupyter Book has become really effective in supporting different languages, ranging from Java to Julia, from C to C++, from Python to Java, and so on. It's got fantastic support for data science, which is basically, you can see a central theme among the courses I teach. But it also has a lot of interactive game elements. Not sophisticated games like 3D games on the Xbox console, but just kind of a fun, engaging activities to promote students to do coding. And we use our own cloud hosting infrastructure. I'm seeing in the chat like that Jupyter Notebook is cloud hosted at various places such as Google's Collaboratory. And so if you use Jupyter Notebook, you can kind of use it across different cloud providers. We use our own and you'll see, like, I'm going to give a demo, and I think you kind of see like some of the benefits of just having a dedicated cloud environment. It brings unspeakable benefit in the age of COVID. Here are just kind of three that that came to mind. It's 100% managed, in that instructors just show up, do the lecture, and the material is persistent. It does not experience bit decay, and it just works as long as your cloud backend is functioning properly. Students don't need any local software to configure. I mean, we encourage students to have their own dedicated work environment, but for the purpose of summative and formative assessments, they simply need to log into the platform and conduct their programming and Q&A exercises all within Jupyter Notebook. And so all they have, the single requirement is that they need to have a decent browser. So something like Chrome or Firefox that's up to date would be all they need for the bare minimal requirements of our courses. And it really is a one size that fits almost all. So, I would say like half of our courses can be done through this type of layout, and the other half really requires some more dedicated environments. For example, things like mobile development is something that's beyond the scope of the software that I'm talking about. Anyway, so here are a whole bunch of courses that have been using this Jupyter Notebook plus a cloud environment, ranging from introduction to programming and to compilers and machine learning. And what's interesting is that there's a course called Introduction to Computer Science for Scientists, and this is for non-CS students. So I feel like this is actually something that could even be offered at the high school level. And we have students who absolutely hate computer science, and they chose to go into math or biology just to avoid computer science. And these students have really over time figured out how to benefit from Jupyter Notebook. Just to answer very quickly, so yes, many students just use a tablet with a Bluetooth keyboard to do these courses. A phone is very difficult just because of the screen size. So the screen size for a mobile phone is just a bit too small for programming. Now, with this, I have been experimenting. I've really been pushing boundaries just to make things fun for myself during the whole COVID delivery over 100% online. I'm a bit of an experimentalist, and I'm at heart, I think I'm a programmer much more than anything else. So I like to tinker and I like to build systems. And in a normal environment, things that I do would be questionable as to whether it's appropriate even, right? Whereas now with the 100% virtual environment, well, hey, there's green light to push the boundary quite a bit. So students are given asynchronous worksheets on a daily basis. So every day they need to do some programming exercises. And if it were in the normal semester, during face-to-face, it will be ridiculous for students to actually come and see me and get a question every single day. Whereas now I can just kind of give them a Jupyter notebook to work on every single day. And it's just one question a day, keeps the doctor away. And there's live group coding, so students can share their notebook and just get together and work on the same notebook. It's also very interesting that I'm able to share with students the notebook that I'm working on so that they see and they can run the code in their own separate containers. And here's a real kick, like a real-time progress monitor. I get to see how the students are progressing and how many times they fail on every single cell. So that's the smallest atomic level. Let me just get to what I want to share with this. I heard a beep. Is that something I should pay attention to?
Sorry, that was me.
Oh, okay. That's okay.
I'll mute.
Now, I wasn't sure if that's like a timer. I got 5 minutes.
Okay.
But I am mindful of the time nonetheless. So can we do something? K-12 computer studies in 2021, okay? There's a sense of urgency because Canada, half of the adult population can pass high school assessment. I mean, I think that's a real sense of urgency, right, among educators. I certainly identify myself as one. Now, I want to think of this as a running joke, maybe. I don't know. Oh, that's some really good question. I wish I can just jump and answer that. Let me just pause the question answering for a bit, and then I'll get back to it at the end of this, right? Now, when I was a high school student, I really disliked biology, and the dislike never dissipated, right? So for most of my life, whenever I come across biology type of material, it just doesn't interest me as much as other fields like physics and math. Now, but if my livelihood depends on it, that's very good. If my livelihood depends on it, I believe that I am qualified to teach grade 11 biology. And the reason is because we have standard textbooks. So I can take biology 11 textbook from Nelson Publishing, which according to Google is what we use, and I'll study day and night and I will teach biology, and I think I'll do a reasonable job. And textbooks are really the crown jewel of education because it allows education to scale, right? Anybody can teach biology. So we can get a lot of biologists who are passionate to teach physics, math, chemistry, everybody, right? Who has kind of gone through sufficient education, but not computer science. We don't have textbooks. And it's such a debilitating lack of teaching material. So I think what if, right? The what if is what I want to focus on. Like, what if we have reusable learning modules? Now, computer science is very difficult because of the technological reliance of the material. Students can't just show up with pencil and paper to learn coding. They really need something more. And so they need a laboratory similar to Bunsen burner and pipette and burette in a chemistry lab, or these swing pendulums and lasers and lenses in physics. So we need something like that. But anyways, nonetheless, what if we can have reusable learning modules? That's not in the form of a textbook, but in the form of some Docker container virtual modules that just you can throw in a cloud environment and load it up. And what if we provide cloud resource to K-12 students? I think one can argue that's already the case, right? My son, who's in grade 7, has a Google account given to him by, I live in the Durham region, by the Durham School Board. And he has Google Meet, he has Google Doc, and he has the Google Drive and everything. He is on the cloud. So why is he not given the computing environment to do coding? Right? That's the whole point, isn't it? So we should give cloud resource to the students directly. And I don't think we should jump fence as instructors to build these infrastructures. They should just be provided to us. It's kind of like asking a chemist to go and extract chemicals for the chemistry labs, right? Like, no, they should just be given, and there should be a catalog where we order these things. And we really should have an open portal. I think what Kathy built, great, right? How reusable is it beyond just a recorded session that Grant is going to post? It'll just go through a bit decay and dissipate over a period of months probably. And students' work, in computer science can absolutely be continuously and automatically assessed. So students really can just talk to a computer instead of a teacher. It's like, did I do it right? Did I do it wrong? And we think we should be able to have all of these things. And let me just show you what we use, and hopefully this it'll take no more than a few minutes really, because I just kind of did this right before jumping into this talk. So let me see if I can pull this one here. Now this is the how the instructor authors the Jupyter Notebook. So it's so you can see that there's so this I kind of made this up, and here's the this is the familiar Jupyter Notebook. For any of you who have seen this, this is the Jupyter Notebook environment, and it's running on our school machine here. And in fact, let me post this this link to you guys. If you want to follow, you absolutely can. Anyone who has a Google account, you can just log in. Maybe I'm just going to, let me just log out to show you. So here you can just log in with your Google credential, and like this is a open platform, so anybody can log in at this point. I'm going to log in as an author here. And that's going to start my container with all the course material. So this really ought to be fairly portable. And here's something I made up. It took me about half an hour to get this right. So I thought, oh, let's talk about lines. Let's talk about lines with Python. And so I have these content module cells that just says, oh, did you know that you can write a function that evaluates the y value for any x position along a straight line using this formula. And so here, if a and b are 3 and -10, you can have a function called myLine that just returns the position of y. And these blue cells are created as work units. So this is what the adversarial environment comes in. We have these work units where students need to figure it out. So here I'm saying, well, you have this myLine code. Now use it to figure out the y value when x is 2.5. And so here's my solution, right? And then we can embed I found a random YouTube video on equations of lines. And you can embed both text and video and, oh, I didn't want to play this, sorry. And then, so students can watch either videos by the instructor. So for me, it's usually just me talking about compilers and machine learning, among other things. And then there's more code, and this is a checkpoint. So we're going to assess the performance of the student. Oh, geez, am I still on that one? Oh, sorry, I forgot to run this. Now I can come down and run this. So that gives a plot of the line. And then we're going to encourage students maybe to, so I'm asking them to implement a function called straight line. So everything is written in Markdown, as Kathy already talked about. And they will be given a blank template to complete. And here's the standard solution. And then we're going to verify how well they did by just running through a couple of challenges. And we're going to ask them to plot the line that they've implemented. And then I thought about, well, can they figure out slopes and intercepts if we give them 2 points? And so here's some sample code. If these 2 points live on a line, we would be able to figure out the slope and the intercept as such. And then we give them a question that says, well, can you implement 2 functions? One's called find slope, the other one's called find intercept. And here's the standard solution. You can see that this is a solution. And we're going to check how well they've done. Okay. And that's the end of it. And the system allows us to export the worksheet. So this is automatically fed to the student. So there are a couple of other steps we can verify. Now I'm going to just show you how the students experience this. So I'm going to log into that website. And if any of you with a Google account, you can just log in. But it has to be like a Gmail account or something. So you can see that in my browser, I've already authenticated to Google, and hence, and then they get this worksheet. So this is what the students get, and they get one every single day. So for all my courses, and they need to run each of these cells to, they read this stuff. And then they keep going. And then whenever there's a red line, that means this is something they have to do. Now, if they don't do it, it says there's a mismatch. It's expecting 2.5, but you got nothing. And so they have to really do a bit of hard work. I mean, not in this case. And then they got it, right? And this little dot, this is actually saying that all their progress is being monitored at real time. So there's a dashboard somewhere that says, oh, you know, Ken has done this at exactly 9:19 p.m. And then they can watch the video, they can figure out, and now they do this. So they plot this. And then, yeah, great. This is what they're supposed to do. And they keep on going. And here it says, well, you have to implement a function. And if they don't implement this function, they'll have a whole bunch of mismatch. Okay. So, so I guess let's try to implement this function. And so like, well, it's not quite right. Now, these students might be a bit cunning. They're saying, I got negative 1.5 and they expected positive 1.5. So maybe I'll just do this. They passed the first one, but it's a wrong thing. So it would fail all the other ones. So they really have to do a bit of a thinking and be a bit more careful. And I don't know how your students are at the K-12 level, but my students can't read anymore. Just because they receive so much information, as Daniel Goleman said, information consumes their attention. So they have so little attention that if you don't give this instant feedback and constantly challenge them, they just don't read. And that's something you really have to recognize. Oh wow, I'm actually seeing people using the system. Okay, that's interesting, but I'll talk more about that. And then the plot, right? So we need to plot this. I'm just going to, the hint is that use the code from above to plot this. So if I were to plot this, there it is. I think I'm supposed to use the straight line. Oh, there we go. It does auto completion, which is nice. So that's the plot. And it keeps on going, right? So if I were to do things, then like I could just return some silly number for the slope and the intercept. And it would just tell me that I failed. And every time I fail, there's a monitor that registers that I failed. Every time I pass, it also tells me that I passed. So as an instructor, I see where students struggle. And I just want to give you a glimpse of what my courses look like running this system. And I think generally speaking, students really enjoy having this. Why? Well, it's not that the system works well, it's that they consume so much information that they want things to be made available to them. Like I'm not sure if it's a good or bad thing, but it is what it is, right? So this is a lecture on just tensors and NumPy, and we talk about it. Like, so I have a video lecture that look at example of what tensors are. Tensors. So, anyways, I hate my voice. And we talk about how tensors can encode things like images and so on. So on the left, it's this commentary. On the right, it's code. And they get challenged. They need to calculate certain properties of this image. And they have to do it on a timely fashion. So going back to my talk, I guess, how do I think it should be made available, freely available to anyone. It's coming, like either like there are quite a number of similar platforms, not quite the level that some of my courses can use, but things like Replit. So I'm going to compile a list of resources, and I haven't had the chance to do so, but maybe like if you put in your email, I'm super happy to follow up, including the system that we use, which is a bit of a Frankenstein custom solution. I'm really hoping to get a university to allow me to make that open to everybody, and you can just have your students log in. Right, okay. Yeah, so there you go. Grant, should I just scroll upward and look at the questions, or maybe you can feed me a few?
Yeah, it's okay. I mean, I think there's some questions about, where the data would reside, and that's just, wherever it is. Like I'm using the Carnegie Mellon site, and they're using some cloud provider.
Yeah. Well, I mean,
I don't really care, but it'd be nicer if there's something in Ontario or something local and privacy and stuff.
So I just put together that server for this evening's event. I really would love to get the resource to get some Google computing credit. Google actually has agreed to give us $6,000 credit in the past to do this kind of educational effort. I think it's possible to launch this openly. So that server, either it runs out of memory or whatnot, but I'm actually appreciative that people actually are brave enough to try it. Now, in the ideal world, we would not need to rely on some Google authentication. We could just hand out, accounts to whoever wants it, right? Just a simple registration, and give us an email and a login, and then we'll email you a URL with your credential or something. So just something like how you buy hats from Amazon. And I think K-12 computer studies is a hard thing because we don't have this kind of portable and time durable textbook quality material. Right. So this is an effort that I think could improve that.
Yeah, and it ties into, there are significant efforts right now to try to help those elementary teachers to meet the new requirements around coding and math, and that's going to be coming in grade 9 as well. But and this, obviously from grade 1 to 4, it's not, they can't type anything, but the higher level grades in elementary, 7 and 8, and then when we get into our courses in high school, a platform like this, we all have the same issues. I like how you kind of said, this is version 1 of, I'm just kind of realizing that as well. And we never had the textbook is still not there, but we don't want a textbook. We want this type of environment. And everything I've tried, whether it's Replit or even the Carnegie Mellon site now, every time there's always some missing pieces to it. And everybody's, I think, finally kind of realizing the missing pieces and trying to make sure it's still private and still flexible, yet unbreakable. Like there's this huge, if you think of a software engineering requirements, it's a huge list of, and not all these providers. But I think it's important to keep it away from, make sure it's not tied to a particular corporation or jurisdiction, and it should be flexible as well. That's why everybody's talking code.org and CodeHS, they all have great stuff, but they're heavily influenced by large corporations, right? And yeah, Sean's mentioning he's out of Maine, and I know New Brunswick has a whole cyber kind of thing there. That so yeah, I love the idea, and I think it just needs to continually get worked through. And our problems in the high school, we can't, unlike in your post-secondary, we can't just say, get a decent laptop and show up to class. That's not, it's like, here's your Chromebook, or, so we can't install anything.
That's, we're not as bad as stuck with Chromebook, but that problem really manifests itself even at our university. So it's very, students struggle with hardware. It's just a constant thing. And I think, I genuinely think that the reason we have textbooks is that we only expect students to bring pencil and paper to school. Well, back in my days. And I think the equivalent to that really is that students should come with a decent sized monitor that has internet access, and that's all we should expect of students, because I do believe that's enough.